Morning. Everyone awake?
Somewhat.
A little bit, getting there. All right, let me move my speaker notes over and I'll be ready to start. So today I am going to talk to you all about dependency management in PHP. And better late than never, of course, because it's existed for a long time in many other programming languages. And but now PHP has arrived at the party. To give you a brief overview of what we're going to go over in our talk, we're going to talk about what dependency management is and how it can help you, how to discover and use packages, and how to write and publish your own packages. Time allowing, we're also going to look at what came before, in particular pair, and look at how using Composer for dependency management can help you with continuous integration. So to tell you a little bit about me, my name is Sequoia McDowell. I am a software engineer at PTC. It's a 3D modeling company, but I work on web stuff. PHP is my first language. I did the typical trajectory of, write your own CMS from scratch, used Pair, Joomla, WordPress, Cake PHP, Slim more recently, and I mention it only to say I've lived the history of project organization in PHP. And although I mostly use Java and JavaScript now, I got to use PHP on a project at work recently. Used Composer and was really surprised and excited to see the way projects are being organized in PHP now. It's really refreshing, and it's making me want to take a second look at PHP. I say better late than never on this talk because, as you know, a lot of communities have been doing this for a while. If you've used Ruby, you maybe use Ruby Gems, or if you use Node, you'd use NPM. And the last thing I want to say is that, again, I'm giving this talk about Composer not because I'm the world's leading expert in Composer, but because I see this as being the future of where PHP development is going. And I think it's a really exciting topic and something that we all should learn more about. And of course, after the talk, feel free to come and say hi to me. So, package management. What is a package manager? I went ahead and pulled a quote off of Wikipedia. But basically, a package manager is a tool that helps you install software. You've probably used one before. If you use Linux, you use dpackage or apt, aptitude, apt-get. If you use Red Hat, there's RPM and Yum. NPM for Node and Ruby Gems for Ruby. So most of you have probably used a package management tool at some point. And the next question is, what is a package? If a package manager is a tool to install it, then what is a package? And packages differ depending on what you're trying to install. Obviously, if you're installing a Debian package, it's .deb. Installing a package on Red Hat, it's RPM. But for the purposes of Composer and PHP, and this is straight from the Composer documentation, a package is essentially just a directory containing something. So a package in PHP is very as an example of this, and I apologize for the contrast here, but as an example of this, I grabbed a package, Zelen and curl. You can see, anybody who's familiar with PHP namespacing, or PSR0, I'm not going to go into that in this talk, but I'll just say that you can see that Zelen in the namespace, curl is a library. You take a look in this package, and you can see there's a Composer JSON. The example and the README are kind of extra. The main thing is the Composer JSON and the source directory, which contains a directory with the namespace and the file name, which is the same as the class name. And so I picked this because it's a very simple example, and also to show that packages aren't big and scary per se. They can be very simple. Some of you may have noticed that I'm kind of switching back and forth between the terms package manager and dependency manager, and there is a difference between the two, which I'll touch on briefly here. A package manager installs packages globally that are or can install packages globally that are to be invoked globally. So for example, if you've ever worked with grunt in the JavaScript world, you do npm install -g grunt, you install it globally, then you can invoke grunt from anywhere. So basically you're installing a tool on your system. A dependency manager installs packages locally relative to a project for the project. And so with Composer, there is no Composer install package name. There is no global Composer install. With Composer, you only ever install things relative to your project. And that's why they make the distinction of referring to it as a dependency manager and not a package manager. It will never install anything globally. So why do you want to use a dependency manager? There are several reasons. It allows for easier installation of an application. You can just clone the project and run a single command. Sometimes you just run a single command. It reads your configuration files and will set up the project for you. There are fewer version conflicts when you're using a dependency manager. If you have multiple projects on the same box, maybe you were sharing some libraries, one of your projects gets upgraded and now you have a version conflict. With a dependency manager, you keep all of this in configuration files. Every project can have its own versions of its own dependencies. You can find problems faster, especially for platform dependencies. As well as requiring, we'll go over this some more in a minute, but as well as requiring a library, saying I require the monologue logging library, you can also declare platform dependencies with Composer, which is to say you can say I need PHP 5.3, I need the person to have curl installed, etc. This is useful because if, for example, your site archives data using bzip and then deletes the data and sets the archives aside, when you go to look for your archives and you discover that bzip's not installed and you check your error logs and there's no archives there and it just keeps complaining that it doesn't have bzip, that's the sort of old way of finding that you don't have one of the things you need for the application. If you have Composer, when you require something, you will find out right when you install that you don't have the thing, so it can save you a lot of headaches. It allows for more consistency and transparency. If you're looking at a project that uses Composer, you know that you can open up the composer.json file, see what dependencies it has, see what it relies on, and see the author, where to get support, etc., and find out a little bit about the project, and which is nice in contrast to getting a new project and having to look all over and try to figure out what's going on. And the last point is just $signs. As well as the benefits of using this in your own project, if you are going to be looking for jobs doing PHP or you work one now and maybe considering shifting in the future, now you can learn Composer and be ahead of the curve. In 16 or 18 months, or in 18 or 24 months, I think if you're not using Composer, you're going to be behind. Shops that use Laravel, shops that use Zen Framework 2, Symfony Framework, you're going to start seeing them asking, are you familiar with Composer, or are you comfortable with it? And so by learning about using Composer now, you're ahead of the curve. You can put that on your resume, makes it a little more attractive. And let's take a look at the bad old days. How do we install projects using PHP? Go get library X from location Y. My project requires plugin A, plugin B, and plugin C. Google, where's plugin A? Where's plugin B? You go get the plugin. Does this plugin work with this version of the framework? I don't know. You go get it and you upgrade the framework. Maybe the plugin has been upgraded since then. Go download it. No, it doesn't. Where do I find the old one? So now you can either email the developer. Maybe they have an old version. It might be hard to figure out even if what version the plugin works with or what library conflicts there are. You could maybe dig through the repository to find an old one if you have access to the repository, but this is pretty tricky this is pretty tricky without knowing specifically what version you're looking for. I didn't know this relied on PHP 5.4. I've had a situation where I was working with, I forget exactly what version of PHP it is. I had a situation where I was developing on my local box, started using anonymous closures in PHP, a new PHP 5 feature. And I was like, wow, great, this is I'm so smart, I'm so clever, I'm using new features. I go put it in production, things start breaking, and I realize that I'm using features that are too new because my production box is PHP 5.1 or something like that. And so use Composer, declare package dependencies, and then you can know, you find out these things quicker. When you're authoring a new library or framework, you roll your own sanity checker. So if you ever run Cake PHP or WordPress, things like that, typically the initial index.php page will say, do you have this library? Can I connect to a database? What version of PHP are you running, et cetera? And all of the libraries, or all of the frameworks and all the CMSs seem to have their own version of this. And that's not terribly bad, but with a tool like Composer, everybody doesn't need to roll their own thing. You can just declare it in one place and everybody uses the same tool, which is nice. So how do we install Composer? It's pretty straightforward. It requires a late version of PHP. PHP 5.3.2 was released in December, so it's less than a year old. So yeah, update your PHP. You probably want to be on 5.4 anyway for those great performance benefits Jonathan Klein told us about. Install it via curl, and then just as a note, you want to move it into your path for easier access. The examples I'm going to give here use Composer in the command name rather than calling PHP explicitly with the Composer far. You can also install it using other methods with curl or without curl, and there's an executable for Windows, and I'm not going to go into those in great detail. But once you have installed Composer, then you install it, you open a terminal, run Composer, and you get this nice, pretty help screen. And I feature this just because I really appreciate the work that the Composer people put into the user experience here, because you immediately get an easy-to-read, concise, colorized help screen. So when you install Composer, I recommend getting started by looking at this. And now I'm going to look at a few more commands to help get oriented with Composer. Diagnose. Composer comes with its own sanity checker. So you run Composer diagnose, and it will check if you can connect to the internet. It'll check that you have the right version of PHP, et cetera. There is the version switch for the version. Help in the command name, and then of course you can increase verbosity, and there's 3 levels of that. I point these out because they're good to help you get oriented. They can make sure that things are working as you expect, and also in particular because if you go to get help with Composer, if you want to go to IRC or you want to go to a forum or Stack Overflow and ask a question, people are probably going to want to know first, did you run Composer diagnose? What version of Composer are you running? Did you increase the verbosity, et cetera? And so these are ways that you can solve problems on your own. So now let's get into the meat of the talk, which is installing a package using Composer. So there's a few different ways to approach installing a package using Composer, and I kind of delineate them based on what you're trying to do. So the first way we're going to look at is if you want to start a new project from scratch, and that's, you're starting a new project, you want to include Slim for routing and Monolog for logging, and that's all you need. Another way is if you want to start a new project based on a framework. So you want to use Laravel or Zen Framework 2, and you don't know exactly what all dependencies you need, or you don't really want to worry about it. You just want to get the packages that they already have set up and get like a standard install. And the third way is working on an existing library or project. And this is to say you actually want to fix a bug in a Zen Framework module, and so you want to check out you want to work directly on that, not use it as a dependency. So starting a new composer project. With this, we're going to create a composer.json from scratch. We just need Slim for our project. Don't care what version it is. This is our first glimpse here of a composer.json file. Has anybody used NPM? All right, so you all, this probably looks a little familiar. We have a JSON object, or we have a JavaScript object. We have a JavaScript object. We have an object, a require object, and then we have a list of things that we need and what versions we need. So this is very simple. We just put that we require Slim in our composer JSON. We run composer install. We see that it's loading composer repositories, etc. It grabs Slim 2.3.1, the latest version, and writes lock files, and it generates autoload files, which we'll go over in a minute. So this is how you start your own, roll your own project. And now you can see after we installed, it's created a vendor directory, and the vendor directory has autoload file, it has composer as a dependency, and it has Slim as a dependency. The next way the next thing we're going to look at is creating a site or project based on a framework. And this is using the composer create project command. Now, when I was first researching composer, I was very confused about when you'd use install and when you'd use create project. There seemed to be a lot of overlap, and they seem to do a lot of the same things. Basically, in the past, what you'd do if you wanted a new cake site is you'd go to cakephp.org, you'd download a zip file, you'd unzip it into place, and that would have everything you needed. Newer frameworks like Laravel, et cetera, don't come in one big chunk like that. They have several pieces. They might have the Laravel router, Laravel ORM, maybe they use a Doctrine ORM, maybe they use some Zen framework modules. And so it doesn't really make sense to zip all these things up in one big ball because first of all, they don't know exactly what you need. And second of all, they rely on external libraries, so they don't want to put those in their own zip archive because if the external library gets updated, you want to be able to get that. And so what they have now, if you want to just have a standard Zen framework, a standard Laravel install, is they use what are called skeleton packages, which is basically another word for a meta package, to say this package contains nothing but configuration to install other things. And some of the newer frameworks have these skeleton packages, so if you say, I don't want to declare dependencies one by one, I just want whatever you think are the best dependencies for a Laravel install, then you can use a skeleton package using create project. There's basically just one command here. We run composer create project Laravel, because we want to start a new site on Laravel. It finds the skeleton project, downloads the configuration, and then runs composer install. Now you'll see it's installing Whoops from Philp, it's installing Elixir from Doctrine, and it's installing the framework from Laravel. What's notable here is as you can see, these are not all Laravel libraries. It's pulling things from a bunch of different locations. And this is why they don't want to package everything together, because they're another thing of note here is that it says installing Laravel framework, which is kind of confusing because we are installing Laravel framework. But the difference is Laravel framework is actually the core dependency of a Laravel project. So you're installing Laravel, which is a skeleton package because you want a Laravel project. You don't want to actually work on the framework itself. You just want to use the framework as a dependency. Also of note, you can see downloading, loading from cache, and cloning. These are three different ways that it can get the packages. The first one, of course, I'm just downloading it. The second one, I've already downloaded it previously, and it has it in my composer cache, so it loads it from cache. And the third, because rather than a version, we're declaring a branch name, it actually goes and clones it directly from the repository. We'll talk more about that in a minute. The last way is when you want to work on an existing project or library. And this is like, let's say you use Composer Create Project, you started tracking your project, you push it to Git, and then you're going to go on another machine and work on your project, and you want to clone it and install it. Or you want to take PHP and do your own modifications on it and send a pull request. This one's pretty straightforward. You clone it. In this case, we found a problem with Monolog, and we want to fix it up, and somehow we have write access directly to Saldic's account. We clone Monolog, we change directory to Monolog, and then composer install. And this is very straightforward, but I introduce it last because I don't want you to think that if you want a new cake project, you go git clone github/cake/cake PHP, because that's not how you do it. You only do that if you actually want to work on that. Now you can modify the package, you can run tests, etc. And that's directly on this project. And in this case, Monolog will be the root project, which is to say, this is the project we're working on. When you declare it as a dependency, it's just a dependency. So now we're going to look at composer.json. But first, I want to take a quick look at a tool that makes it a lot easier to create these composer files. When we first looked at creating the composer file from scratch, we just opened a text editor and wrote it. But that's kind of tedious. So we're going to look at composer init, which if you've used npm, again, it's a lot like npm init. So we run composer init. We have a new project. And it says, hello, this is the composer.json generator. So it asks you a few questions. What do you want to call your project? I'm calling it client site because I'm making a site for a client. What is the project about? Who made the project? A little metadata. Minimum stability is an important key in your composer JSON, because this declares what the minimum stability of packages you install are. So I'm doing a client site. I want everything to be stable, so I say stable. If I'm working on something for myself, I want to use bleeding edge libraries with the latest versions and latest features. Maybe I move my minimum stability down to dev. That'll allow me to install less stable packages, or I move it down to beta or down to alpha. And then you can install less stable packages that have newer features. But for now, I only want things that are in stable release. License is proprietary because it's a private project. And this is a really neat feature of Composer init, it lets you interactively define dependencies. And it asks, would you like to declare your dependencies interactively? And I say yes. So Slim is the only thing I need right now for this. It's a nice little router. If you haven't used Slim, check it out. It's kind of like Sinatra or Flask. So we search for the package. I type in Slim. It comes back with some results, and it indexes them so you can refer to them by number. It's getting these results from packages.org, which is the main Composer package repository. And it says, which one of these do you want? I say 0. I'm looking for Slim. That's the one I want. You can also see there's a Slim skeleton package right now, but I'm not using that because I don't want all the other Slim stuff. I just want the router. You enter the version that you require. We want version 2. Then, do you want any more packages? No, we don't. And then it gives us the output of the composer.json that we just made, and asks us to confirm. And so as you can see, this is a lot quicker, a lot easier way to initialize a new Composer project. I will say that some parts of Composer init are a little rough around the edges. Sometimes it's not clear what happens when you press enter. I was learning when I did this that if you don't put a version string in, I thought that it would just require any version. It actually thinks that you decided you don't want that library and doesn't include it at all. It's also not clear if you start doing something you want to cancel how you get out of it. But it's really good to just to get you started, and I believe it'll be improved upon. So now that we've got our new project, we've got our new Composer JSON, we can install it. Run Composer install. And now we want to use the dependencies that we just installed. So in our index PHP, we want to use Slim. So we require vendor auto load. And what this does, we're only loading one library here. But if you had 24 libraries, you don't include them all. You only include vendor auto load. As you can see, it says writing lock file and generating auto load files when you install. It looks through all your dependencies, and then it rewrites the autoloader in such a way that you just require that one file. And I won't go into autoloading because it's a whole other topic, but basically it means that you don't have to include things explicitly. They will be included when you try to instantiate an object. So here when we say new Slim, it looks and says, OK, load Slim. And then we can start using Slim. Now you would, at this point in the project, you would want to add your composer JSON file to Git, add your composer lock file to Git, and add your code, and then start tracking. So composer JSON, this is where the magic happens in Composer, and we're going to look over the anatomy of it. What it contains typically is it lists package information, tells you about who made it, where you can find the source, where you can get support, etc. Defines dependencies, what does this package rely on? Declare where the files in your package are. It's just telling Composer, because it generates an autoloader, it needs to know where your source is. And then constrains what type of packages, what types of dependencies are installed. We looked at that a little bit with minimum stability. And it does more. So we're going to step through the Composer JSON for Monologue. I'm picking on that project again. It's written by one of the people who I think writes Composer. So it gets used as an example a lot. So the first block here we've looked at already, the name, description, and keywords. The description and keywords are significant because these get used by packagists to identify and help people find your packages. So if you search logging, this is going to come up. They have the home page here, so you can find where to get information about the library. They have type, which is an interesting key because this is a library. Other types, possible types, are project, like the project we were making for Client X. Meta package, like one of the skeleton packages, or Composer installer. And these are things that I think are going to be used a lot more in the future. You could have a type called WordPress plugin. And then when you're defining your WordPress dependencies, WordPress plugin installer type can have its own install logic. And so if they say, don't just put things in the vendor directory, it's WordPress, so we need to move things into our plugin directory, well, you can do that with your own installer type. Authors, more information about where the package came from. And now the juicy part, require. Now here you can see an example of a platform dependency. They're requiring PHP greater than or equal to 530. They're also requiring PSR log, which you'd say this is a logger. Why is it requiring a logger? It's actually requiring a log interface. And there's a few ways to define these different to define exactly what version you want of something. You also see the require dev key, which is if you're checking this project out because you actually want to work on it, there are some additional packages you need to install. These are not used for people who are just using it as a dependency, but these are required if you need to work on this package. So the different ways we're defining versions here, as you can see, there's the greater than or equal to, there's the tilde 1.0, there's 1.0 star, and then you see dev master. So the greater than or equal to is pretty straightforward. Start here, install anything beyond that, or require anything beyond that. The tilde means you can increment the last digit. Now here it doesn't really make sense to do tilde. I don't know why you did that. You should have done 1.star. But if you needed 1.6 or higher, but you couldn't use 1.5, then you would do tilde 1.6, which is saying start at 1.6, and then you can increment from there, but stop before you get to 2. The star is pretty straightforward, 1.0 star. And then at the bottom we see CouchDB requires dev master. Now with this they're saying, I don't want a particular version, I want whatever is the latest on the trunk of the repository. And so they're specifying a branch explicitly. Suggest is another key that comes with these. When you install this project, even as a dependency, it will say, hey, you're installing Monologue. Maybe you want to install CouchDB. Maybe you want to install a Mongo extension, or maybe you want to install Mongo on your system so you can log to that. So this is another useful way to discover more packages. And then there's the autoload key. This one, when we spoke earlier about telling Composer where to find your source, that's this. With autoload, this helps it generate the autoloader. And what this says is, I have a PSR0 module, which means it autoloads in a particular way, Google PSR0. It's in the namespace Monologue, and my source can be found in the source directory. So this is, if you use source, you can put source. If you use lib, if you put it in, my name / whatever, you can tell it where you want it to be. And then under extra, they have a branch alias, and this is just pointing dev master to, or this is pointing 1.6.x to dev master. So one of the things I'll note here is that there's not a version key. And the reason there's not a version key is because Composer uses tags and branch names in Git to track versions. And so it's discouraged to put, it's frowned upon to put a version key in here because it's better to use Git tags, and packages will just figure out your versions on its own from that. So I want to look at some root-only properties because that was a library. It didn't really have many root-only properties. And these are properties that will get used in the root of your project, so in the composer.json in the directory that you're working in, but not for dependencies. So they don't get called recursively. Required dev. Again, we said if I require monologue as a dependency, it doesn't install the dev dependencies, only if it's, if for my project, I want to use PHP unit for testing, I'll put PHP unit as a dev dependency saying, you don't need this if you're just deploying, but if you want to run tests, then you need PHP unit. Minimum stability, again, this is depends on your personal preference, and so it only works in the root of the project where you can change it. Repositories, if you work in a corporate environment and you say we don't go straight to GitHub, or we're in our own little network, we maintain our own dependencies, you can point this to a different repository to say, don't go to Packagist, go to my local space. Config, this is where you can configure the behavior of Composer itself, where dependencies are installed, how much space to use for caching dependencies, process timeout, etc. There's scripts, and this one's interesting. This is where you can define pre-install, post-install, pre-package, etc. logic. So for example, if you say after you install this, then I need to bump the version information, or I need to reset Apache, or something like that. You can add these in post-install scripts, and then you can push it to your server and run Composer install. It gets the new dependencies, and then it restarts Apache. So the scripts are kind of fun. So all this seems to work. We've got easy way to install all our packages, but how do you ensure that the application will work after install? What if a minor library change breaks something? We say we want 1.2.star of a library, and it works fine, hunky-dory. Then we go push it to our server. In the interim, the people who were making that library updated it, and now the new version doesn't work. So how do we ensure that when we install everything that it's going to work? Or let's say we leave a project for 12 months and go pick it up in a year. You don't want it to reinstall all new versions of everything when you just want to make a minor change. So enter the composer.lock file. So this is kind of a shadow of your composer.json. When we were doing install, it said generating a lock file. What this does is it records the exact dependencies that are currently installed and where they're from. And so if at the time of installing Cake PHP, you say use the latest version of Cake 2, and the latest version is 2.3.1 at the time of installing, it will record that. So if 2.4 came out and you run Composer install again, it'll still go to that 2.3.1. So when you're installing, it actually looks at the lock file first. And only if it doesn't find the lock file will it fall back to the Composer.json and generate the lock file. You want to check this into your version control system. Check this into Git because this is the type of thing you want to track exactly what version are we using right now. You can use the exact same libraries from the same locations across all servers. And if you want to start working on a project, a year later, 2 years later, you can know that the same things are going to work. You update the log file with Composer update. So when you are ready to try new dependencies, maybe you check out the project, run Composer update, run your tests, see if things work, touch test, everything appears to work, then you can check in the new log file. So next I'm going to talk briefly about finding and adding packages. So there's a couple ways to find packages. One of the prettiest ways is through packages.com. There's also composer search, and then the command to add packages is composer require. So using packages, we want to use Twitter Bootstrap in our project. And so we go to packages.org, search Twitter Bootstrap. It pops up, the first result has 65,000 installs. 27 people have started it. The second result has 1,000 installs and 0 people have installed it. And this meta information is very useful because we can say, aha, I bet this first one is what we're looking for. You click on Twitter Bootstrap, and then you can see the page for it in particular. I have the home page, the source URL, issues tracking, what the main branches to require, what versions you have down here on the bottom. And remember that all the information in the top is derived from the composer JSON. The information on the bottom with the versions is derived from branch and tag names. So no one set this up. They just put a composer JSON on their project. They put keywords in there. They said my keywords are CSS and Bootstrap. And it automatically generates all this. But we don't want to use the browser-based search because we're cool, awesome developers who use the shell all the time. So we want to find things with composer search. And so we're looking for the same thing. Rather than searching Twitter Bootstrap this time, I just searched Bootstrap. Because composer is configured to use packages.org by default, we're going to get a very similar set of results. It comes back with Twitter Bootstrap, some other Bootstrap things, components, etc. And we want Twitter Bootstrap, and so we've searched for it. Then to add it, we use composer require. And when you run require, as I was saying, there's no composer install package name. If you run that, it's going to say too many arguments. Composer install only installs composer JSON. If you want to install something local to your project, you use require in the package name, and it will, well, you have to give it a version number, and then it will update your package JSON and go install the thing. And you can note that it does not update the lock file. So now when you concatenate your composer JSON, you can see that there's this new dependency there because we did not have one before. So now you've got a great package. You're ready to share it with the world. You want to publish to packages.org. So how do you do this? Well, you paste your repository location and hit check. And that's it. And going back to that Twitter page we saw with all the information about it and how many times it's been installed, what are the versions, where do you do the issue tracker, where's the canonical source, what tags are there, what's the description, et cetera, who wrote the thing. That's all in the package JSON. All you do is you point it to your place, particularly on GitHub, because Composer actually has explicit GitHub integration. You point it to your repository, and then it parses all that stuff out by itself. So it's very easy. And briefly, how packages works. It gets packaged and metadata from composer JSON. It lists release versions based on tag names or comparable branch names. And user can also require branches directly using dev and the branch name. Scans the repo once a day for new code. One note on searching in the terminal versus searching on packages is that on packages you get the information about how many people downloaded the thing, and you can also see version names. That's something that composer search does not have, unfortunately. So now briefly I want to talk about doing continuous integration with Travis, and we're getting short on time, so I'm going to move through this quickly. So if you haven't heard of Travis continuous integration, it's continuous integration for open source community. And basically what this means, it runs when you push to GitHub. It can test against multiple versions of PHP. You get notifications on build failure, et cetera. What continuous integration does, if you haven't seen it before, is it basically says every time I update my code, I want to run the tests. I want to build the whole system and run the tests. Now in PHP, we don't have builds per se because it's an interpreted language, but with something like Composer, you can have builds. So when you set your project up with Travis, you put a Travis YAML file that tells it how you want to test your project. It and then you set up a hook on GitHub, and then every time you push your code, Travis will grab it, it'll install it, and run your tests. And the best part of Travis, which you may have seen on some people's GitHub pages, are you get this nice little build passing badge when your build is passing. And, or if your build is failing, you get build failing. To look briefly at a Travis YAML file, and I know that I'm not showing you Travis, but I just want to whet your appetite. Here you can see, this is again from Monologue. They say the language is PHP. This tells it, what kind of virtual machine it should use. And then this is the part that I think is awesome. They say test PHP 5.3.3, test PHP 5.3, 5.4, and 5.5. Now, this is something I'm never going to get to myself. I'm not going to update my project and then test it in like half a dozen different PHP versions. But if you're using Travis as a continuous integration tool, then you can, and that's pretty great. There's a before script that says composer install, and you can see rather than having some bash script or some convoluted means to get all the dependencies, they just do composer.install with the dev dependencies and prefer source because they want to get the newest stuff. And then after it's done that, it will run PHP unit and tell you whether you're, well, if your build passes, it won't say anything, but if it fails, then it'll email you. At 40 minutes, I want to quickly go over what about pair. Has anyone here used pair? Okay, good. We have pair users in the audience. Great. I've also used pair. I think pair is pretty good. I asked the pair people and the composer people, why did pair never catch on? Because composer is catching on as a dependency manager. Pair never really did. And I'm going to go through some of the reasons here. There's only one channel for a long time, and it was hard to get packages into that channel. You had to install, there's pair the installer and pair the libraries, the repository. And pair the repository was linked to pair the installer, and it was hard to get packages into the repository. And that caused people to not be excited about it. PHP lacked namespaces. This made it hard to install things side by side or switch, just mix and match what you want to install because things would often collide with one another. Frameworks, when Zen Framework came along, they didn't use pair, which didn't help pair. People who were looking for an official PHP code base might go and use Zen Framework. They released it in one big monolithic chunk, and this was not in line with package management in general, and other frameworks followed suit, and so that hurt pair. Many packages were not upgraded to PHP 5. The authors said they worked pretty well, and they didn't update them, and a lot of authors left the pair project, and they didn't get replaced. Pair offered things like code hosting, issue tracking, versioning, etc. GitHub did all these things. Also, Composer or Pair requires server software. Composer does not. You can just point it to a Git repo and install from there. That's another barrier. The Pair software, they also told me the server software was poorly documented and difficult to install, and so people never really used channels. Some of its successes. Pair people told me the successes of the Pair installer itself, which still gets used a lot. Many projects have channels still, so if you use Zen Framework, you can install stuff from Pair still, or a lot of different projects still maintain Pair channels. DB2, or DB and DB2 and MDB2, there were some notable successes of Pair. And it's still used, it's the only way to install PHP extensions, or it's the only tool for installing PHP extensions. So that's what about Pair. So, in summary, today we talked about what and why of package management, talked about how to package your application, how to share your application, and how to test and how that can be helped out using Composer. And so with this information in mind, you can find my slides here online if you want to look at them. I'm _Sequoia on Twitter. Feel free to email me and go forth and package. And are there any questions?
So you had mentioned that when you initially create the composer.json, it'll create a log file. But when you later on decide that you want a dependency that you use require or want to update the log file, is there an additional parameter that you can pass into that command, or is that something that you have to manually
I'm not sure, but I know that you can update package by package. So you can do composer acquire library X, and then composer update library X, and then it will update your lock file only for that dependency. Does that answer your question? The question was, how do you essentially how do you add one dependency to your lock file, right?
When you're using the composer require.
Yeah. And so how do you add one dependency to your lock file? Use composer update the dependency name. Another question?
Yeah, when you upload a package to packages, does that then show in composer search?
The question is, when you upload a package to packages, does that show in composer search? And the answer is yes. Composer, by default, you can point it to lots of different repositories, but by default, it is linked to packages.org. And so when you upload a project to packages, which you're not really uploading it to packages as much as you're telling packages where it is, and it will go and crawl it. Once it crawls it, which it does once a day, it will be in it'll be in the repository information on Packagist, which is like a big long list of all of the packages that they have available and the meta information about them. And then when you run search, it will send it to a Packagist API endpoint, and it will return your package, yes?
You know any good resources for integrating Composer with the legacy code base?
With the C code base?
Legacy.
Oh, legacy code base. Yeah, that's going to be with the legacy code base. If you're using things that don't have, if it's not architected this way around like, discrete dependencies that you're installing separately, I think it's going to change the way that you need to get the things that you're trying to install. And so if you're installing, if it's Cake PHP and you're using 3 different plugins and none of them are on Packagist, well, either you can explicitly declare where they are, say this one's over here, this one's over there. Maybe they don't use semantic versioning, so maybe it's not easy to say what version. I don't really think it's totally worth it. If you want to like overhaul a legacy code base, yeah, but if you but it's not going to be worth trying to put this on a complex legacy code base, no.
There we go. Composer is still relatively new. Do you have any insight into where it's heading? What features will be added in the next year? Stuff like things to look forward to.
Yeah.
Just curious where it's heading.
Yeah, so the question is, what's on the roadmap for Composer? I actually asked the Composer people this directly, and they said basically the Composer installer, they have some bugs and things to work out, but they feel like in terms of features, they're pretty much there. They have most of the stuff that they want to have in terms of features. It does. I didn't go into everything that it does because it does even more stuff, but I asked them this question, and they were like, no, there's not like a lot more stuff on the roadmap.
Cool. Keep it simple, right?
Yeah. And it's, when you pop the hood, it's pretty complex. There's a lot of stuff going on. It's a very powerful tool. Anybody else?
Working in a corporate environment, we have to deal with proxy server. You can deal with the proxy server via curl, but I've popped the hood on the Composer source and it uses file get contents. Do you know of current workaround for a proxy server or integrating Composer with an environment where you use a proxy server?
The question is, how to use Composer through a proxy server. And you're saying HTTP traffic and stuff doesn't just go through the proxy server?
It does, but there are certain things that are whitelisted and blacklisted where
Get packages added to the whitelist?
that's a long process, but if you put in your credentials, it also requires authentication, which is a main version of curl would work, but file get contents would not.
I think I don't know the answer to that. I think the best I'm going to say is use SSH tunneling and point Composer to localhost. Sorry. All right, I think I'm on time, and you had the best questions, so here's a book. Thank you, everyone. I guess I'll disconnect. Here, let me turn these things off.